Okay, in this lesson we're going to learn about what happens when we have a power raised to another power. And I'll start with an easy example. If I had something like m to the power of 3 and I put brackets around the whole thing and I put another exponent 2, how do we work with this and how do we make this easier? And there's two ways to work with it. There's a long way and then there's a shortcut way. I'm going to quickly show you the long way and show you afterwards a much faster way to simplify this. If we think about this, this 2 is telling us I have 2 of whatever's in the bracket. So if I wrote it out, it really means m to the 3 times m to the 3. And if we simplified it, we know that because the bases are the same, they're m's, we can add their exponents. So really it would just be m3 plus 3 would equal m6. Okay, that's great. That's an easy one, but sometimes you're going to deal with more complicated ones that will take a long time to work this way. So there's got to be a faster way. The faster way that you're going to learn is the third rule for exponents, and that's if you raise a power to a power, you are going to multiply the exponents. Okay? So, in our example here, we could have just very quickly just said, okay, whatever's inside will multiply with the outside. So the 3's on the m, it's going to multiply with the outside exponent, and you get m to the 6. That's way faster. So that's the rule we're going to use, and the reason it works is because if you wrote it out and did the long way, you of course would have to add together all your m's, and you do get m to the 6. So let's use this faster rule to figure out a few different examples, and I'll give you a few examples that we can do together. The first one here would be something like 2 to the power of 3, and I raise it to the power of 3. So you ask yourself, which rule am I using? Rule 1, Rule 2, or Rule 3? We're going to be using Rule 3 because we're raising a power to a power, or an exponent to an exponent. Okay, so you would just use your shortcut, multiply it out, 2 to the 9, done. If you had something with maybe more than one thing in the brackets, now you're going to have to be really careful. And so let me show you this example. This is the second example. So we're going to have 3mp2, and it's all raised to the power of 2. So what this is saying is I have 2 of everything in the brackets. And my little hint to you is this: put an exponent on everything. Okay? So the 3 doesn't have an exponent. There's only one 3, so put a 1. There's only one m, so put a 1. And the reason I say that is it reminds you that all the exponents in the brackets are going to multiply with the outside. So the 3 to the 1 has to multiply with the outside too. The m to the 1 also has to multiply with the outside too. And the p to the 2 also multiplies by the outside. So all of them were multiplying by the outside bracket. And when you clean it up, you now get 3 to the 2, m to the 2, and p to the 4. Leave your answer in exponent form, you're done. If you looked at something like 3m2pk and you raised it to the power of 3, I'm just going to change color pens here, and I'm going to remind myself that there's really a 1 on that 3, there's really a 1 on the p, and a 1 on the k. So I have 1, 2, 3, 4 things that are all going to multiply with the outside exponent. So when you write this out, you would have 3, 1 times the outside exponent, m2 times the outside exponent, p1 times the outside, and k1 times the outside. Clean it up, 3 to the 3, m to the 6, p to the 3, k to the 3, and everybody's happy. So that's all there is for rule 3 is if you make sure that you put 1s on all your items inside, then you won't forget when you have to use the power to power rule. Okay, I want you to try a couple examples at home right now, and I'll just write them out for you really quickly here. So what I want you to try is 2m squared k and raise it to the power of 2. So that's your first example. And your second example is going to be 3r3p2 to the power of 3. So I'll give you a second to do that, and if you want you can pause the video right now and try them yourself so that you don't see the answer right away. But I'm not going to sit here and wait, so I'm going to write them out for you. So I'd suggest here that you pause the video and try these yourself and then check to see how I solved them. On number 1, it would turn into 2. Remember, there's a 1 on the 2, a 1 on the k. So I'm going to go 1 times 2, because this is the outside one. M times the outside one. K1 times the outside one. So it should be 2, 2, M4, and K2. So that's the answer for 1. The answer for 2 would be put a 1 on the 3 and write out the work. The 1 would multiply with the outside 3. The R3 would multiply the outside, and the 2 would multiply the outside. So when you clean it up, you get 3, 3, R9, and P6, and everybody's happy. So hopefully you got those right. If you didn't, go back and try them again and figure out where you went wrong. Okay, the next little part is taking a look at sometimes you're going to have negatives. And you're not going to run into this a lot of times, but I'm going to give you a little bit of a shortcut that will hopefully make it easier for you to solve. And here's what I mean. If you think about it, let's just start with no numbers. Let's just think about negatives. If I had negative times a negative, we know that equals a positive. Okay, it's a double sign rule. The other way I could rewrite this is, how many negatives do I have multiplying together? I have 2. So I'm going to put a negative, put it in brackets, and square it. Because that really means negative times negative, does it not? Because it's saying I have 2 of the negatives multiplying together. If I wrote negative to the 3 power, it really means negative times negative times negative. And if I did 4 or 5, you would just write them out. Now, the little shortcut here is, if it's even, it will always be positive. And here's why. It's because you're always, with evens, you're always going to have the same numbers of negatives pairing off. So if I had negative squared, it's always a negative times a negative will always be positive. If I had negative to the 4, it would be negative times negative times a negative times a negative. These ones would turn into positive, and so would those ones. So it'll always be positive. It's only when they're odd do you have a leftover negative sign. And here's what I mean. If you had negative to the 3 power, it really means negative times negative times negative. The first 2 would cancel and turn into a positive. So now I have a positive. The positive times the negative will always be a negative because you always have one leftover negative on an odd number. So just remember this rule. If it's an even exponent and you have a negative in the brackets, make it positive. And so where that would be useful is here. Okay, so if I had something like negative 2m3 and I squared it, deal with the negative first. Will you have a negative in your answer or will you not? Is that an even exponent on the outside? Yes, it is. So it means my answer will be positive. Then do the question like we just showed you before. Put a 1 on anything that doesn't have an exponent and multiply it by the outside. So you're done the negative, you don't have to worry about it anymore. Now do the rest of the question. 2 to the 1 will multiply by the outside, and m to the 3 will also multiply by the outside. So now you get 2 to the 2 m to the 6, and we know it's positive because we figured that out, and we're done. And that's basically all there is to working with power to power rule. And if you're not sure how I got some of the steps, you might want to watch this video again.